for version controlling, and GitHub is the platform which is used for storing our code. On your local system, you first have to already have Git. Sorry, I already have Git. So what I can do is, let's say I want to work on a project. So first I will create a folder called, right, and I'll inside that folder, and let's say I want to create a in C++, and let me call it a main dot, and here I just want to print something. Okay, so more there related writing, but it's just I want something. Folder I have got C do version code. The first thing, installing, and then I'll be running the Git. As all in my folder get started to be version control. Okay, and once I have written all my files, I will push my code on GitHub, right? So that other developer, they can take this code by using this URL. They can just run git clone command and paste that URL. And in that case, all the files related to my project will be downloaded. And then the other developer can start working on it, right? This process that you see is still manual. Now, if I add a tool called Jenkins, right? Like I have a tool called Jenkins, and if I want to do this process automatically, in that case, I can just create a job called code checkout. Okay, there are different types of jobs in Jenkins, but for simplicity, I'm taking the freestyle project. And now here, what I will do, I will configure this job so that my code is already checked out using Jenkins. I don't have to go through this manual process and do the cloning by myself, right? This was the first two. So now let us see what is the next step that is done in software development. So first thing that you did is check out your code. Either you do it manually, but in DevOps, everything is automated. So that will be done using Jenkins plus Git and GitHub. Okay. So here Jenkins is actually a web server which can automate any kind of task. In general, in DevOps domain, it is called CI/CD server, right? So everything that you are going to see, every phase of software development cycle will be configured and integrated with Jenkins. All the tools that you use in different phases will be configured with Jenkins. Jenkins will be the person who is going to automate the complete process. So in our first step, we will have to integrate Git and GitHub with Jenkins. Second phase is compilation of your code, or you can say building your code, right? In this case, we have different tools available for different languages. Like for Java, we have tools like Maven and Gradle. And for Python, we can use Python interpreter. If you're on a reactive website, in that case, you might be React language, and for which we have a tool called NPM. .NET we have tools like MS Build and NuGet, right? Similarly, for every language, we have our compilers and interpreters, right? So our second tool that we should have in our system is Maven. I already have installed Maven, so I can work with any Maven, any Java project. I can compile any Java project on my local. But my purpose is to automate everything. So I will be integrating these tools, Maven or Gradle, with Jenkins, right? If I want to compile this, I can go to Jenkins and I can create a new item, which is called Maven project, or I can even use freestyle job to create and configure my Java project with my Maven tool. Like I have configured Maven with my Jenkins tool. I have configured Git with my Jenkins tool, and also I have added GitHub credentials, GitHub platform details with my Jenkins tool. So my Jenkins server, what it will do, it will automatically take the code from my GitHub account. It will it will do the compilation using our Maven tool if I'm working with Java project. And if I'm working with some other languages, in that case, I can integrate all those tools, right? So I have mentioned my Git location, I have added my Git credentials, and I have also provided my Maven details, right? So whatever tool I need to use in the software development cycle, I will have to integrate everything with Jenkins. Likewise, the third part, that is the third phase of our software development life cycle, will be to package this, package our software. When we say package, means like, let's say you have created a website and that website contains images, some configurations, right? And when you compile that, in that case, you are actually getting some exe, which will be run on some server. But since that exe will require these configuration and images, so what I can do is I can create a package and then deliver this complete package to my deployment server where everything can be handled, right? The third part will be packaging. Earlier, packaging was done, but they were distributed in folders, shared in folders. But now, for maintaining these packages, the versions of these packages, we have a tool called Artifact, JFrog Artifact. They provide us repositories to store our packages, like GitHub provides us repositories to store our code. Artifactory provides a repository where we can maintain our packages, right? Next phase that we do in DevOps is code coverage. When we say code coverage, earlier code coverage and code scanning was not taken seriously, but now due to security concerns and improving the quality of software, we do code coverage. When we say code coverage, that means we are going to scan our code against some rules. Okay, let's say there is a fresher who has come into the team and he is writing code without following the developers convention, right? Maybe he is using unused variables, like he may have declared some variable called var1, but he is not using it anywhere, right? Or maybe he is creating lots of loops in his code. Okay, maybe he's using nested loops in his code, or maybe he has created some pointer and he has forgotten to allocate or deallocate that pointer, which can be accessed by the hackers. And using that pointer, hackers can go into your code and do changes, right? So for this purpose, for finding out these issues, we have a tool called SonarQube, right? The purpose of this tool is to scan your code and find out all these such issues, and then it will suggest the development team or the developer who has written the code to fix all these problems. And once the problem is fixed, then it will allow the code to be promoted into the next level, right? So in SonarQube, we write some rules, like if you find some pointers, if you find some security hotspot, or if you find anything that is going to harm our project, then please create a report and send it to us so that our developers can work on it, right? So now in almost every project, SonarQube phase, which is called code coverage, is introduced. Okay. And we have parameters set for these types of tools, like your team might have said that 80% code should be scanned, which means if you written 100 lines of code, then in that case, if 80 lines of code is fine, then you can promote your project for further involvement, like for testing or maybe for deployment, right? So these are the important phases that is covered until you create the packages of your project. And until this point, it is called build automation, build and package automation. And you can add all these tools with your Jenkins server, right? Like I have added SonarQube as well. I have added Artifactory as well. I have added all the build tools. So code coverage and everything is taken care. And my project, which I have created on Jenkins to run, is okay. And we will be able to see our packages on JFrog Artifactory, right? Until this, the process is called build automation. All the tools that you have seen till now, they all will be connected and integrated with Jenkins, right? Now comes the deployment part. Deployment means you are going to move your code on some production level server, and from there you are going to run your project or your application. Like if we talk about Amazon, okay, so this is actually a e-commerce project which is running actually on some server. Okay, it may be the case that it is utilizing or it needs 1500 servers or more, right? So this Amazon website that you see is actually running on some servers. And how it is running, for that, all build process or build automation might have been done, and a package was created for this Amazon website where all the images that you see, all the product details that you see, they have been mentioned, right? And once everything is ready, the complete code was moved on the server and they just started this application. And due to which we are able to see this application from our browser by just typing amazon.in or whatever the server you want to access, right? So for deployment part, we will go back once again and understand how deployment was done in earlier days, right? So let us say you have created your folder, your project folder, you have compiled, you have gone through the complete build process, and now you are ready with some exe, some configuration file, and maybe some images, right? So in our earlier days, we used to directly deploy this code, or you can say directly move this code onto some server and just start the application, right? When the number of servers were limited. What people used to do, they used to run more than one application on the same server. Like you can go to the market and purchase a server which is having like 512 GB of RAM, very high capacity computer, and maybe 2 TB of storage, right? So earlier what was happening on a single server, let's say multiple applications were running. Let's say one application was written in Java, other was in C++, and the third was in .NET, right? So here there is a high probability that at some point of time, Java application may start consuming 80% of CPU, right? C++ may C++ application may start getting down, right? And the same might be happening with it, because they may not get the enough message that they need to run on the server. So what people did, they came with concept of virtualization. Okay, said that on a single system, we can create more than one system. Create one system and hardwares. If you've got 512 GB of memory, ways we can system build resources on all these systems, right? One option was to computers and applications individually on these systems, right? But in that case, there may be the problem of resource underutilization, right? Let's say C++ application is not used by many users. Then in that case, if you have added a computer of 512 of this computer being used, right? People came with a concept of virtualization, that on a single machine, we can create multi-machines, and if they are not required, we can just turn that virtual machine off, right? So in this scenario, now you can run your application on these individual servers, and limited resource that they will be having will not be accessible by other applications, right? And the environment will be completely isolated, and there will be no such issue of underutilization, or you can say high utilization, right? But working these virtual machines were a complete operating system. They needed a complete operating system, and at times they need to get upgraded, add security patches, and follow everything what a single computer was required, right? And also to distribute these machines to other environments, like if you're working in development environment and if you completed the code, then you will be moving your code to QA, and from there you'll be moving it to staging and finally to production, right? So in such scenario, if you want to distribute these machines into, or if you want to promote these machines into other environment, then it was very difficult to manage, right? In virtualization, hardware sharing is done. Hardware sharing of your host computer is done, right? But our Linux operating system, they had some features like chroot and namespace. Don't worry if you don't know about them, and you also don't need to understand them in deep, right? The main functionality of these two features of Linux operating system was to isolate group of processes, right? If you know little bit of Linux, then you might be knowing that whenever you run Linux, everything runs as a process, right? The first process that is run in Linux is init, and from there all other processes are created, right? So parent process of every process running in Linux is init, which is called root process, right? And then you can run all other processes. So let's say you are running init process and you are running C++ application. And for running your C++ application, you need all these three processes. Similarly, for Java, you may need all these three processes, and for .NET, you may need all these three processes. So Linux said that I have an option, I have a feature which is having a functionality where you can group all these processes and you can also change the root. Okay, you can create a new root of your process and you can use chroot feature of Linux to create a complete group of processes, right? So here, when you create a complete group of processes, what you get here is a share of operating system, right? And all these group of processes will be having common functionality. Like if you are working with Java, and let's say this is your Linux operating system where you had your init process, and maybe in your Linux operating system, you had other utilities and libraries which you were using, right? In this case, if I am isolating some processes, so what I can do is I can take only those processes which are required to run my application, right? Like for Java, I can use JVM and my bytecode and whatever it requires, right? And I can just isolate them by changing the root. And then I have another feature in Linux, which is called namespace. Using this namespace, I can decide how much resources of this computer where this group of processes are running can they share, right? So now what I have done, I have created a kind of lightweight virtual machine with some group of processes having common features, right? And I have started calling them as containers, right? So here you see, I don't have anything else. I just have only those processes which is required to run my application. I don't need these utilities. I don't need any library. I don't need anything from Linux operating system. I just needed those processes which was responsible for running my Java project, right? So I just grouped them together and let's say I cut them from the main process tree and I took them somewhere else and I can run them in a complete isolated environment, right? And this isolated environment with these groups of processes are called containers, right? Docker is a tool. If you are an expert in Linux, you can create containers by running all these commands like chroot or namespaces, but you don't need to do that because we already have a tool called Docker, which will do the same process behind the scene, right? And it will offer us some commands using which you can create containers. Okay, it will isolate the processes, it will completely create a new environment, it will group your processes and give us the containers. You don't have to worry the logics and everything that we need to create a raw container, right? So Docker came with all this functionality where you'll be able to do the containerization part your application. In our build automation, we had ended up with packages, right? So now I can create a container first, get these packages into this container and simply run this container. So this container will come now run my application without having interruption from outside world, right? The best benefit of this containerization is I can run it on any system. Okay, I can run it on any system. Any system means I can run it on a physical machine. I can run it on a virtual machine, or I can run it on a virtual machine created on a physical machine, or I can run it on a virtual machine created on cloud. Once the container is created, I can run my application anywhere, whether it is on-premises server, virtual machines, or cloud platform, right? So this phase, which is called containerization, requires Docker tool to be integrated with your Jenkins tool. So right here, we have configuration available for Docker as well. So now you can add Docker details. I already have Docker installed. You'll have to install Docker in your system. Okay. Earlier Docker Docker was installed with two components, client and server. Now they have come up with Docker desktop. For Linux, Docker desktop was not available, but now Docker desktop is available for Linux as well. In Linux, you had to install using the command line, but now you can directly install Docker desktop, which will do the complete containerization for you. Okay. And you can integrate it with Jenkins, and your containerization phase will be automated, right? Once you've created your code, your package is created. Now you can containerize your code, and you will be creating a file. Once you've created you have decided to isolate the processes. In that case, you can save it as a template. Okay, let's say I want to run a Java project. So I'll think I can get a file where I'll be installing everything that I require to run only those isolated processes. And I want to save this file. This file is called image, your Docker image. Okay. And when I'll run this file, it will become a container. Okay. Earlier applications were written in monolithic architecture. Okay, where we had a complete single process running everything with lots of files, lots of configuration in just one project. Okay, let's say if this is your e-commerce project, and in this file you have written a payment method. Okay, and you had to do some changes in your payment method. If you have done some changes, in that case, the complete project was needed to get recompiled and built, right? So now people came with new options, which is called microservices, where they have broken this big monolithic application into small applications and integrated them together. So I can just break this, bring out all these methods with new application name, and then I can integrate them for communication purpose, right? So all these new sub applications that I have created, they are run inside containers. Lots of containers are now created for any application, right? That is why we require Dockerization, you can say containerization of our application. And we need to store all these images that we have created into some repository, for which we have a platform called Docker Hub. Like we had GitHub for storing source code. We had Artifactory for storing our packages. Similarly, we have Docker Hub where we can store our images, right? We also have other tools. We also have services from different cloud platforms, but Docker Hub comes with your Docker tool installation. You can access Docker Hub directly on internet. You can go Docker Hub. You can create your account like you create on GitHub, and you can find, you can just move your images in your Docker Hub account. Now, since the application are broken into many sub applications, in that case, lots of containers are created, right? If you know about Geo, Geo is an application which you install in your phone. It uses at least 25,000 containers, right? And all these images, they store it some in their own server. They have created their own repository. Maybe they are using Docker Hub or anything, but they are having almost 25,000 containers running just to support this application, right? So now for running these 25,000 applications, or you can just reduce number for understanding. Let's say the number of containers are 250. So for running these 250 containers, you might need virtual machines and servers, right? You can directly deploy all these containers on these servers and start working on it, right? But the problem here is if some of the containers goes down, or if some machine goes down, in that case, you'll have to attend all these issues manually, right? And there may be chances that you are using a database in your application, which is having some credentials. You can say username and password, which is used by your applications to access your database, right? So in such scenario, there will be high chances that your database username and password, or you can say credentials, can be stolen, right? So to manage all these containers, to run all these containers, to handle all these computers where you are running these containers, we do container orchestration. All this process where you manage lots of container and other required things associated with those containers is called container orchestration. And we also have a tool which is called Kubernetes. Okay, Kubernetes is responsible for handling all these container orchestration, right? The structure of Kubernetes says that we will have a cluster of computers, okay, where we will make one machine act like a control plane. This will be a control plane. And from here, it will manage all other systems where you'll be running your containers will be running on these systems, not on the control plane, or you can also call it as master, right? So all other containers will be running on some on other machines that is present in that cluster. They are called nodes. Okay, so this complete picture that you see is called Kubernetes. Okay, Kubernetes is mainly responsible for attending the failing nodes, the failing containers, restarting containers, building copying containers, adding some more machines, deploying more containers if required, right? So all such things are handled by Kubernetes, right? Now you can install Kubernetes in your on-premises by creating lots of virtual machines, or you can take help of cloud platforms, right? On cloud, you can spin up lots of clusters, lots of computers, create clusters, make one of them as master and others as worker nodes. And then you can just deploy your application and run, right? But let's say you are an e-commerce company and you have declared that tomorrow is going to be a big billion sale day, right? And on a normal day, the traffic that was coming on your website was, let's say, 10 million. But on the big billion day, you are expecting that this traffic may go up to 50 million, right? In that case, to handle such huge amount of traffic, you may have to create these clusters. You may have to create more such type of clusters so that your application can run smoothly, right? So let's say when your big billion day started, And at the starting of the day, there were 10 million, and after 1 hour, the number went to 25 million, right? So in 1 hour, it will be very difficult for you to add more clusters and configure them to run your application, right? So to handle provisioning and configuration of these computers, we also do infrastructure automation. Okay, which is done by tools like Terraform. Okay, Terraform is mainly responsible for creating these servers. And we have another tool, which is Ansible, which is responsible for doing the configuration part of these servers. Configuration means they may be deploying some tools or adding some new softwares on these systems so that they can handle my application. They are compatible with my application, right? Most of the computers, most of the virtual machines, or you can say servers, they are now being created on cloud platform. So Terraform is a tool which is able to communicate with any cloud platform like AWS, Azure, GCP, Oracle Cloud, Alibaba Cloud, whatever it is. And it is able to communicate and provision these systems very quickly, right? So what we can do now is we can set up an alert or a threshold that if the traffic goes to 10 plus 1 million, let's say it is going to 11 million. So at that time only, create a set of 50 virtual machines. So Terraform will immediately get alerted by the notification, and it will start provisioning these clusters. So by the time your traffic goes to 25 million, there will already be some computers created which will be enough for handling 25 million of traffic. And then we can again have an alert using which more computers can be added and they can handle more traffic, right? So Terraform, Ansible, they are used for automation of infrastructure, right? So let's say now our application is running on a Kubernetes cluster. We have containerized the application and they are running on a Kubernetes cluster. And I want to find out how my application is performing. So what I can do is I can either open the logs of my system, okay, and read line by line whether some warning is coming or not, or some data is being manipulated properly or not, right? Or what I can do is I can use tools like Prometheus and Grafana, which is going to read these logs and show us a dashboard. Show us a dashboard where it will inform us about everything happening with my application as well as with my infrastructure, right? So if I see that on computer number 2, one container has died, one container is not working properly. So I can see that there is an alert for computer number 2, and I can immediately log on to my Kubernetes cluster and fix this issue, right? So the benefit here is before your application goes completely down, you'll be able to find out your problems and bugs earlier only and fix those issues, right? Now this Prometheus and Grafana, they can also get integrated with Jenkins, right? So Jenkins here is the core person. He is the master of this complete automation part. Parallel to the Jenkins tool, there are a lot of more tools that are now available in market. Cloud providers, they have also created tools like Jenkins. Like we have Azure DevOps, which is responsible for doing this complete process automation. AWS DevOps, we have a tool. In Azure DevOps, it is Azure Pipeline, which will be doing everything like Jenkins. It will be responsible for everything. We have code build in AWS, which is going to do the same thing. And on GCP, we have cloud build, which is going to do the same thing. Then we have other tools, other options available like GitHub Actions, right? We also have Build Kite. We have Travis, Argo City. Lot of tools are available, but most popular is actually called Jenkins, right? Jenkins says that either you configure everything using the UI part or you just write a code and tell me what are the steps and automation I need to perform. Tell me where are the tools located, where are the tools available in your system or on the system where I am running. Just write everything in this file and let me run the complete automation for you, right? So this thing that you write is called Jenkins file. Right? And it will do the complete automation for you, right? From getting your source code checked out from your repository, building it, doing the Sonar Cube part, doing the automation part, doing the containerization, and deploying it on Kubernetes cluster, right? So this complete automation thing is now a very important thing, or you can say it is a mandatory part of IT industry, right? If you think that you'll be able to do the manual testing and process the code to our next environment, that is not going to happen. All the new projects that are being developed now is going to follow the DevOps principle, right? And all older projects are being migrated on DevOps. Okay. The software development cycle, which was used earlier, like agile or waterfall, they will be still used, right? But the process will say that everything should be automated using these DevOps tools, right? Now, talking about the cloud platforms, like we have majorly three cloud platforms: AWS, Azure, and GCP. More than 50% market share is of AWS, around 25% or more or less is for Azure, and 10% maybe of GCP, and rest is for other cloud. Maybe the number has changed, but these two are also getting popular nowadays, right? Now, if you talk about cloud computing, like I said, when in earlier days, when people were involved in deploying applications, they were doing it on physical servers or virtual machines created on physical servers in their data center, which was located in their premises. Like if you are creating an internet banking website of ICICI Bank, right? So what ICICI Bank people will do, they will create a data center in their own location, and they may ask a company to develop their website and just deliver the code, and they will be responsible for running this code. They will not ask the company to run this code. So ICICI Bank will buy computers, ask the company to provide the details of running this website, and they will just run it on their own data center, right? But let's say ICICI wants to expand in New Zealand, right? In that case, again, they will have to set up everything on in New Zealand, whatever city they want to expand, right? Or in any geographical location, if they want to expand, they will have to set up their data center, right? The cost of setting this data center will involve purchasing all the systems, purchasing the network devices, purchasing all other hardwares that you need, plus maintaining a team at each location, right? Maintaining a IT team at each location. And there may be situation that some natural calamity may come, some war may happen, like we are witnessing Ukraine and Russian war, right? So if the scenario was that if Ukraine was having some data center, that might have got destroyed, right? The company holding that data center will be at loss, right? So maintaining the infrastructure at company's location was very costly, right? So some smart people, what they did, they told that let us create data center around the world. Okay, lots of data centers around the world. Okay, and ask companies to utilize these data centers at their own location just by using your browser and internet. Okay. If you need a virtual machine, you don't need to go to the market and purchase a new virtual hardware and then install a virtual machine on it. If you need, just contact us. Okay. And we already have hardware set up in different locations. We will tell you how to create a virtual machine. We have already written the manuals. We have written all the processes, where we are also offering you different methods, how you can create them. And then you can simply create the virtual machines. Or if you need a database, in that case, we also have database. If you need network, we have network. If you want to do artificial intelligence thing, in that case, we are offering those types of server as well. If you want to migrate your infrastructure from your on-premises, from your company location to our data centers, you can, we have provided provision for that as well, right? And the best part, they told that you don't have to think of managing these servers. We are going to take responsibility of everything, but we will offer you to use these things in different ways. Like if you want to get a virtual machine and do everything by yourself, like installing and everything. So in that case, only the hardware part, the power to that hardware, and the configuration to that hardware will be taken care by us, and the rest you can take care, right? Like you can install your own operating system, you can install your own application, right? But if you need to start a virtual machine which is already having installed some software, then in that case we do have those types of machines as well, right? If you don't want to worry about the infrastructure, in that case you just give your code to us, okay, and we will be running your code, and you don't have to worry where your code is running. We will make sure that your code is secure and they are running properly on the infrastructure that we have created for you, right? Or if you want to use any application where you don't have the code, as well as you don't have to worry, you don't want to worry about the infrastructure, in that case we have those options as well, right? In first case, where these people are providing everything, is an example of IaaS, which is called infrastructure as a service. The second one, where you are just giving them code, right, and you're not worrying about the infrastructure, is called PaaS, which is platform as a service. The third one, where you're not even giving the code and not worrying about the infrastructure, is called software as a service, right? So all these things are being provided by this cloud platform. The major category of services that they offer, they involve the compute part. Okay, when we say compute, that means they are going to give us machines and other things where you can just simply you can configure and run your code. Storage, they are going to give us hard drives for storing our data. They are going to give us databases, different types of databases that we need for our applications. You can use relational or non-relational database, whatever type of database you need, they are available by these, made available by this cloud platform. They will be creating networking for us. You can create your network and you can configure your own network. They are also giving us migration part, migration services, right? And they are also giving us options to connect through VPNs using different networks, right? They are also giving us containerization services. So if you don't want to use your own Kubernetes, they are giving us Kubernetes as well. Like in Azure, it is AKS. In AWS, it is EKS. And on GCP, it is called GKE. Okay. And if you want, we will give you repositories as well, right? You don't want to store your code on GitHub. We people are giving you repository. You can store those repositories, your codes in our location, whether it is source code or packages or your images. You can store everything at our using our services, right? Now they are expanding and providing services to other domains as well, like for IoT, like for AI, for data analytics, right? Every cloud platform, they are coming with pre-configured system, which they can use, which people can use for doing all such other projects, right? And they also come up with an important part, which is called identity management and identity management, where they are going to give you mechanism to decide who will be able to access the services as well as at what level they'll be able to access services, right? Like you have Terraform and Ansible, so they also have alternative for Terraform and Ansible as well, right? It depends on company's project, what type of project they are working on, and what actual services they are looking to decide which cloud platform they are going to use. Okay, like GCP is mostly used when you are working on a large volume data, right? If your project is having large volume of data, if you're working on data analytics project, so nowadays the common choice is GCP. If you are more interested in, if your company is mostly working with Microsoft tools, like you have Outlook, you have .NET projects, you are working with Teams, anything connected with Microsoft, then in that case, mostly people are going with Azure, and in all other cases, they are going on AWS. Every services for everything is provided by all these cloud platforms, but they have some specialization for some languages and tools, right? All these services, like we talk about Microsoft Azure. So you see, we have a lot of services available by them. And if you see the category of services they are offering now, earlier they were having a limited category of services, but now they are expanding day by day. And the category of services that you can see is they are providing it on AI and machine learning, analytics, compute, containerization, databases, hybrid and multi-cloud as well. So now you can develop projects which is running on Azure as well as some component may be running on AWS. So identity, integration, Internet of Things, everything is now taken care by these cloud platforms, right? And they say that either you can use the console part. Console is actually the UI, where using which you are able to access the cloud services. Or they say that if you are a programmer, in that case, we have development kits available in different languages, which is called SDKs. You can write your program in different languages and use our services, right? Or you can use our CLI tool, which is command line tool. So like if I want to run with Azure, I can just do Azure login and it will help me to get login into my Azure account, right? Similarly, for AWS, we have tools which is called AWS CLI. Okay, and for GCP, we have gcloud. So we have command line tool available, we have SDKs available, and we also have APIs, okay, which you can use. So tools like Terraform, they use APIs, right? SDK, you can write programs, okay, like you can write some programs and you'll be able to access your cloud services, or you can use everything that they have provided, right? In automation part, mostly the APIs are used, right? And if you're writing a script, Linux script or Python script, in that case, you can also use the CLI commands offered by these cloud platforms, right? So here are the details of DevOps and cloud. And now if you have any questions, you can just go ahead and ask. Anyone? Hello? Right. Virtualization is creating virtual machines, and let's say you have created some virtual machines, right? And you are running an application on those virtual machines. Let me remove this first. Right. And we can take example of that big billion day. And your first computer was able to handle, let's say, 5 lakhs of traffic, and then others were able to handle similar traffic, like say they are able to handle 5 lakhs traffic each, right? So at the starting of your big billion day, you may find that some traffic has started coming on these systems, some may be going on this system, some may be coming on this, and others may be going on this, right? You may find that only 3 lakhs are here, 4 lakhs are here, and only 1 lakhs are here, and let's say 1.5 lakhs are here, right? So in such scenario, you may find that some of your systems are being underutilized and some of your system may get overutilized. So for that purpose, you set up a tool called load balancer. What it does, it just redirect all your traffics on different machines and balance the traffic, right? So it will say it will follow a mechanism according to which if 10 million traffics are coming, then in that case it will distribute the traffic on these systems equally, right? So virtualization is different thing. It is related to creation of virtual machine. Load balancing means whatever the traffic load is being directed on your website is taken care, or you can say balanced on all the machines running behind that load balance. Anything else?
No, thank you, Professor.
Okay, okay then. I'll stop sharing my screen, and I think you'll be able to get
Stop
the
the recording, sir.
Yeah. Okay.
Stop the recording so that it will be stored in cloud.
Yeah.